Hello, everyone. Welcome to the lecture on Introduction to Data Warehouses. We're going to look into the fundamental concepts of what a data warehouse is, understand why it's a critical component of modern business intelligence, and look into its basic architecture. So let's first go over a definition of a data warehouse. A data warehouse is a large, centralized repository of data collected from various operational databases and external sources. So the primary purpose of data warehouse is to support decision making and business analytics by providing a single source of truth for historical and current data. And warehouses matter because they are crucial for organizations, since they consolidate disparate data sources into one repository, therefore improving data quality and consistency. And this allows the organization to uh, do advanced analytics, reporting, and data mining. Let's talk about key concepts and terminology. So in the data world, there are two main types of systems: operational and analytical. Operational systems, they're also called online transaction processing or OLPT systems. What they do is they handle day-to-day transactions such as sales, inventory updates, and customer service interactions. Analytical systems, on the other hand, are designed for analysis, insights, and decision support. And these are also commonly referred to as online analytical processing systems. So, also, there are four defining characteristics of a data warehouse. Subject-oriented is the first one. So, subject-oriented means that they are organized around key subjects or areas of business. And integrated is another characteristic. And you say data warehouse is integrated if they are consolidating data from multiple inconsistent sources into a consistent format. Third characteristic is non-volatile. Uh, what this means is data once entered is usually not changed or removed. It's mostly read-only for analytical queries. And lastly, uh, data warehouse is time variant. What they do is they store historical data over long periods, enabling trend analysis and forecasting. Data warehouse architecture overview. Uh, we there are six terms that we want to talk about: source systems, staging area, data warehouse layer, data marts, and BI tools or analytical tools. First, let's talk about source systems. Uh, so the data, the journey of data begins in operational systems such as customer relationship management or enterprise resource planning systems, and external data feeds like social media or market data. And these systems generate raw data that needs to be harmonized. And then it goes to staging area, and this is an intermediate storage area where raw data is temporarily kept before being cleaned, transformed, and loaded into the main warehouse. It's essentially a buffer to ensure data integrity, quality, and consistency. Next is data warehouse layer. So once data is properly transformed, it's loaded into the central repository, often organized in schemas like the star schema or snowflake schema. So data is structured to support broad and detailed analysis. And then data marts, this is an optional component. So sometimes specific business units or functional departments require specialized views or subsets of the data. And you can think of data marts as mini warehouses that are tailored for those specific needs. Finally, business intelligence and analytics tools such as dashboard, reporting engines, or data mining applications connect to the warehouse or data marts to provide insights, visualization, and interactive analysis for end users. Now let's talk about the ETL, ELT process. They stand for extract, transform, load. Let's first talk about extract step. And this is the first step that involves collecting data from various sources, which could be relational databases or flat files, uh, third-party APIs, internal APIs, or external web services. And the extraction must be done carefully to ensure minimal disruption to source systems and to capture relevant data. After extract step, you go to transform step, and in the transformation stage, data is cleansed, standardized, and formatted according to defined business rules. So for example, we might want to convert date formats, unify naming conventions, remove duplicates, and handle missing values in this stage. This ensures the data is consistent and meaningful. Once data is cleansed and transformed, you go to load process, load step, which means that data is loaded into the data warehouse. And this can be done in bulk or incrementally, depending on the business requirements and the volume of data. And in some modern systems, especially those leveraging big data technologies, ELT can be used. This means data is loaded first into a large scalable system like a data lake, and transformation happen later on demand. Uh, by doing it this way, by loading first and transforming later, we are taking advantage of high performance computing resources within the data platform. Let's move on to data modeling in the data warehouse. Let's first talk about why data modeling matters. Data models define how data will be organized in the warehouse for efficient querying and analysis. So proper modeling helps optimize performance, reduce redundancy, and improve data quality. And we can talk about two major schema. They are star schema and snowflake schema. And the star schema is the most common design. Uh, what happens is this star schema has a central fact table, and this fact table contains quantitative metrics such as sales amount, quantity, surrounded by dimension tables that describe the context. And context meaning time, region, product. And this schema is called a star because uh, if you look at the diagram, it looks like a star with the fact table at the center and dimension tables in a radial pattern. Snowflake schema is a variation of the star schema. So the snowflake schema normalizes some of the dimension tables into multiple related tables, which can save storage but may introduce complexity in querying. And there are two tables that you want to know when data modeling in the data warehouse. They are fact tables and dimension tables. Fact tables, they contain measurements and metrics related to business processes, such as number of sales, total revenue, and dimension tables contain descriptive attributes about the facts, such as date, location, product details, or customer profiles. Lastly, let's talk about measures and attributes. When we mean measures, we're talking about numeric data that can be aggregated. So we're talking about sum of sales, average transaction amount, and so on. And when we talk about attributes, we're talking about descriptive fields that are used to slice and dice the measures. So this could be region name, time period, product category. Moving on, let's compare and contrast data warehouse versus data lake. So as data management evolves, many organizations also implement data lakes, and data lakes are large stores of unstructured or semi-structured data. So while data warehouses impose a defined schema upon data as it enters, data lakes allow you to store raw data first, defining schema later. So that's the two difference. Data warehouses, uh, their schema on write, data lakes, their schema on read. And the structured versus semi-unstructured. So data warehouses, they typically store structured data that's already been cleansed, conforming to a known schema. And data lakes, they can store not only structured data, but also semi-structured and unstructured data. So this can be uh, CSV files, log files, or images and videos. So I talked about schema on write and schema on read briefly. Uh, and I said data warehouse says follow schema on write and data lakes follow schema on read. So schema on write basically it that happens when data is modeled and conformed before loading into the data warehouse. And schema on read is data is stored in its raw form, and schemas are applied when queries are run. So when do you use data warehouse and when do you use data lakes? Data warehouses are best for traditional business intelligence reporting and analytics, where data is well defined, and data lakes are ideal for exploratory analytics, data science, and also storing diverse data types that might be used in the future. Common tools and technologies. Uh, let's first talk about commercial and open source technologies. So there is a wide array of tools and technologies available for building data warehouses. Some are proprietary commercial solutions with sophisticated features, while others are open source offerings that can be cost effective and community driven. In terms of ETL or ELT tools, We can talk about uh, three tools. First one is Informatica Power Center. It's a widely used commercial platform with a robust suite of data integration and data quality tools. The second one is Talend. It's an open source alternative that offers various data integration capability and a user-friendly interface. And last, Apache Airflow. This is really popular open source workflow orchestrators for data pipelines. Now let's move on to popular database systems. Oracle database, Microsoft SQL Server, IBM DB2 are traditional relational databases with enterprise-grade features, and Amazon Redshift, Snowflake, Google BigQuery, they are cloud-based data warehousing solutions that offer scalability and pay-as-you-go models. And Azure Synapse Analytics is Microsoft's cloud platform for analytics, combining data warehousing and big data processing. Lastly, for business intelligence tools, uh, Tableau, Microsoft Power BI, ClickSense, they are widely used for visual analytics, dashboarding, and interactive reporting. And Looker, SAP Business Objects, they offer advanced analytics and enterprise reporting capabilities. Data governance and quality, it's let me first talk about importance of data governance. Data governance involves setting policies, standards, and processes to ensure data is secure, consistent, and used responsibly. In a data warehouse context, governance is essential for maintaining accuracy and trustworthiness of insights. Master of data management, short for it's often referred as MDM, and MDM focuses on creating a single consistent definition of key data entities like customers, products, and suppliers across the organizations. And this prevents issues such as duplicates or conflicting information in reporting. And let's move on to talk about data quality dimensions. We can talk about four of them: completeness, accuracy, timeliness, consistency. Uh, when we mean completeness, we're ensuring there are no missing fields or records. We talk about accuracy when data values match the real world or source systems. And when data is up to date, that is timeliness. Uh, and when data does not conflict across different systems or tables, we refer to that as consistency. Last one is metadata management. Let's first talk about what metadata is. Metadata basically describes how and when data was created, transformed, and used. So having robust metadata management makes it easier to track, understand data structures, and ensure compliance with regulatory requirements. Best practices and implementation tips. You first want to plan for scalability. What we mean by that is you want to design the data warehouse with future growth in mind. As data volume or the number of users increases, the system must be able to scale seamlessly. And it is important to maintain incremental loads. So instead of reloading the entire data set each time, that can be really inefficient. Uh, it's important to implement incremental or delta loads, only loading the changes to cap, and this makes inserts, updates, delete efficient and reduce processing overhead. Third, you want to implement strong security. So given that a data warehouse often stores sensitive and critical business data, it is important to ensure uh, security measures such as role-based access control, encryption, and auditing, continuous monitoring and optimization. It is important to monitor performance metrics, query speeds, and system resource utilization, and definitely use indexing, partitioning, or caching to optimize query times, and schedule regular maintenance tasks like vacuuming or reorganizing table structures if supported by your platform. Last, training and documentation. It is important to provide end user training to analysts and stakeholders who run queries and create reports. Now, moving on to use cases and future trend. Let's first talk about use cases and uh, talk about how different sectors uh, have different use cases. First, let's talk about retail. In retail, a data warehouse can combine sales, inventory, and customer data to optimize pricing strategies, forecast demand, and personalized marketing. And in finance, such as banks and insurance companies, they can use data warehouses for risk analysis, compliance, and detecting possible fraudulent activities. Healthcare, healthcare providers and insurers, they can use data warehouses to store patient records, treatment outcomes, and operational data to improve uh, patient care and reduce cost. Now, let's talk about cloud data warehouse and growth of cloud data warehouse and lakehouse architectures. Ever since cloud, the shift to the cloud has been dramatic. So with platforms like Snowflake, Amazon Redshift, and Azure, Synapse offering easy scalability and lower maintenance. Also, the lakehouse concept merges the best of data lake flexibility with data warehouse structure, and enabling both large-scale raw data storage and schema-based analytics in one platform. And also AI and machine learning integration. So advanced analytics, machine learning, and AI applications increasingly rely on data from warehouses or lakehouses to train and deploy predictive models. And this integration is driving new levels of automation and insights. The example could be in recommendation engines or uh, detection systems. Last is real-time data warehousing. Uh, Traditional data warehouses, what they do is they update data in batches, but real-time or near real-time data warehousing capabilities are emerging to support time-sensitive decision making. And this is becoming especially important for businesses that require rapid responses to market or operational changes, such as e-commerce sites or financial trading platforms. Conclusion. So we cover the fundamentals of data warehousing, what it is, why it's important, architectural components and best practices. And these insights should give you a strong foundation for further exploration of data analytics and business intelligence. Thank you everyone for listening.